Hello viewers, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to the channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, stacks, queues, linked lists, trees, graphs and so on. Please check them out. I have uploaded the code for this problem to the GitHub repository. You can get the link from description below this video. Let's jump into today's problem. Decrease elements to make array zigzag. Given an array nums of integers, a move consists of choosing any element and decreasing it by 1, right? So move is nothing but decreasing the element by 1. So an array A is zigzag array if either every even indexed element is greater than adjacent element or every odd indexed element is greater than adjacent elements, right? So basically the zigzag definition is given here, right? So there are obviously, if it is an array, right, so there are even indexed numbers and odd indexed elements, right? So it could be either even indexed element is greater than its adjacent element or odd index elements could be greater than its adjacent elements, right? So basically you need to get the array into zigzag fashion either by following the first condition or second condition. It doesn't matter whatever the condition that we follow. But finally what we need to do is return the minimum number of moves to transform the given array to zigzag. So move is nothing but decreasing the element by 1, right? So if you decrease the element by 2, that means it's 2 moves. If you decrease the element by 10, it's 10 moves, something like that, right? So one move is just decreasing it by 1. So that's the assumption. So finally what we have to do is we have to transform the array into either the first condition or the second condition. So as mentioned here, right, so the array index starts at 0, okay? So is A0 should be greater than A1 and A1 should be less than A2 and A2 should be greater than A3 and A3 should be less than A4. So that means 0, 2, 4, so these are the even indexed elements, right? So even indexed element should be greater than the adjacent element. So this is greater than this one, and again this is A2 should be greater than A3 and A2 should be greater than A1 also, right? So that's the case with the even indexed elements. Similarly for the odd indexed element also, right? So A1 should be greater than A0 and A1 should be greater than A2, right? So it could follow either this order or this order. So we need to transform our array, right? So let's go ahead and look at the example, right? So basically you have 1, 2, 3. This is a very toy example. It's easy actually to understand, right? So 1, 2, 3, right? So if we say the first condition, right? Let's say first condition we are going with. So every even indexed element is greater than the adjacent element. So that means every even index. So what are the indices here? 0, 1, 2, right? So here what we can say is every even index element is greater than the adjacent element, right? So even index. So this should be greater than, this should be greater than the element here. What we can do here? So if we transform 2 to 0, right? That means decrement. So we are allowed to only do the decrement, right? No increment. Incrementing is not possible, right? So if increment was possible, right, we would have said okay 3, right? So 3 is greater than 2, right? And 2 is less than 3. So that is possible answer. But we cannot do that, right? So we can only decrease. So what we can decrease? Obviously this we want greater than this, right? So that means we have to decrease this to 0 and then so now move on to the next element A1, right? A1 should be less than A2. A1 is this one, right? 0 is less than 3. Yes. So this is what is answer, right? So what is the move count? Basically minimum number of moves is min moves is equal to 2, right? Because we converted 2 to 0. That means we decreased 2 times, right? 1 time is 1 move, 2 times is 2 moves. So moves is 2. That's what we are saying. So let's say this is with the even index, right? even index. Let's go with the odd index, right? So 1, 2, 3. Go with odd index. What we are saying is again 0, 1, 2, right? So what we are saying is A0 is less than A1. Yes, A0 is less than A1. That's correct. And A1 should be greater than A2. A1 should be greater than A2. So in this case, what we are going to do is, so to the whatever there in here should be greater than here. That means we have to decrease 3 to 1 possibly, right? So that means how many minimum moves needed from 3 to 1? It's again 2, right? So min moves is equal to 2, right? So if you solve with even index or odd index, then minimum number of moves are 2 only, right? So what we have to essentially do is we have to solve this particular array or make this array zigzag by using even index and odd index and get only the minimum moves possible. But in this particular case, it so happened that minimum moves in both cases are same, 2 and 2. So if you look another example, right, just considering another example, we will go through that and we'll jump into the other thing, right? So 0, 1, 2, 3, 4, right? So now let's call even index, right? So now we will go with even index for this. So even index means A0 should be greater than A1. Yes, A0 is greater than A1 and A1 should be less than A2, right? A1 should be less than A2. That means since we can't increment 1 to 7, we have to decrement this 6 to 0, right? So that means 6 becomes 0, right? So how many moves we incurred? So min moves is equal to 6 as of now. And then moving on, this A1 should be less than A2. A1 should be less than A2. Good. But A2 should be greater than A3. A2 should be greater than A3. So that means again, so we need to get this down to 0, right? So how many moves we encountered? 6 plus 6, 12. So this we are doing with even index, right? Good. And next moving on, A3 should be less than F4. So 0 is less than 2. So that means we have minimum number of moves for even index is 12. So let's go with odd now, okay? So if it is odd, A0 must be less than, right? A0 must be less than A1. This must be less than this. So how can you make this less than this? So if you decrement this by 5, that means make 4, make this 5, right? Make this 5. That means min moves is equal to 4 as of now. Min moves is equal to 4 as of now. And then moving on, so A1 should be greater than A2. 6 is greater than 1, good. And A2 should be less than A3. So 1 is less than 6, good. And A3 greater than A4. 6 is greater than 2, right? So min moves is 4 with odd index, right? So what is the minimum of even index versus odd index? It's 4, right? 12 if you want to follow the even index, and if you want to follow odd index, it's only 4. That means answer is 4, right? So in the previous case, it so happened that we just need 2 for even or odd, but here even we need 12 moves, but for odd it's only 4 moves. So we will return 4. Why? Because we are looking for minimum number of moves. So array can be zigzag following even or odd, it doesn't matter, but we are looking for minimum number of moves. So in this particular case, we will say minimum is 4, because 12 and 4, what is the minimum? It's 4, right? So on the whole, there are the n elements in the particular array, right? So we are saying there are 2 different orders possible, and while we make those orders, whether following even indexed or odd indexed, you keep on counting the moves that are required. The thing is, you need to go through the entire array 2 times, one by following even indexed, one by following odd indexed, right? So which of them, whatever you do, finally the minimum moves collected during even index and odd index. Just return the minimum of both. That's the answer that we are looking for, right? So let's go ahead and look at the code for this particular problem, right? So here I'm going to show you the code with two different approaches. So first we will see one approach where we are using extra space, and we will look at another approach where we will not use that extra space, right? So here what we are saying is, okay, n is the length of the array A, right? So I am saying even and odd, which is initialized to 0 to start with. I have another array called B, which is initialized with the same length of A, and copy all the elements from A into B. So essentially what we are doing here is just take a copy of A into B, right? And after that we follow this, the even indexed approach first. First we will do the even indexed approach and calculate the even minimum number of moves for even index. So I have even and odd, right? So these are the variables which I am going to use to keep track of the moves with the even index, moves with the odd index, right? So here one condition is required, right? I am going to compare the next numbers, right? So I want to make sure the next number is still less than n. Basically the index s, index I plus 1 is still less than n. If so, then we go forward, right? If it is last element, obviously we don't have to do anything, right? Simply. So now what we are saying is even indexed elements, right? So even indexed element. So now check if it is less than or equal to ai plus 1, that means next element, right? So if so, what we are saying is it should be greater than, right? But if it is less than or equals to, we need to keep calculating the how many moves we need, right? And update the corresponding element, just like we have been doing, right? So even index, so here we have updated, right? So it to 5, right? So we want a0 should be greater, right, than a1. So in this particular case 9 is greater than, what is that, 6. So we were fine, right? So similarly if it is not, then we will do this calculation, but if it is, we don't have to do, right? This is for the even indexed elements, but for odd indexed elements we will do a different one. What we are going to do, odd indexed elements. So if a1, right, so basically we are still trying to do the even indexed element is greater than the adjacent element, right? That means we have to make sure the odd indexed element is less than its adjacent element, right? So a2 should be less than, sorry, a1 should be less than a2 and a1 should be less than a0. That's what we are trying to make, right? So that is what here we are doing. So even doing that, if there is any calculation incurred, that means the element movement is incurred, we keep track of that also, right? So essentially we are doing that here. So this is what we are doing with the even indexed element, right? So whatever the even that we have accumulated, that will be the minimum number of moves for even. Next we will go through similar, same thing, similar code, right? But instead of doing with ai, we are going to do with array b, because we have manipulated the array a already, right? So if you will see, we have manipulated the array a, that's why we cannot take anything from ai, because array a is already manipulated. So we'll need to look into bi, which is a copy of b, which is a copy of a anyway, right? So while looking for the odd indexed elements, so similarly we will check whether the next element is less than n, and check if it is a even indexed element. So this is less interesting for us, because in the odd indexed element we have to make sure it is greater than the adjacent element. So that's what we are making sure. If it is less than or equal to, we will do some manipulation. If it is already greater, we don't have to do anything, since it is already greater, right? So if it is less than or equal to, then we will do something, right? So finally we accumulate the odd count for moves. So when we go through the even indexes and odd indexes, right? So whatever the minimum available moves, minimum of even and odd, we just return that, right? So this is how we are able to solve this problem. This exactly follows the process that we have discussed here, right? So let's go ahead and look at the time and space complexity for this, right? Time and space, right? So what is the time? So we are going through this array A and filling the array B, right? So that means order of n, right? Assuming there are n elements in the array. And then we are going through the array A here and trying to do the calculation of how many even indexed moves are happening. So that means another order of n, right? Again. So here for odd, again we are going through the entire array to calculate the odd number of moves on array B, right? So that means one more order of n. So it will be totally order of 3n, but since we are going to remove the constants from the big O notation anyway, we will say time complexity is order of n. So let's go ahead and look at the space complexity. Are we using any space here? We are using a variable n, even, odd, right? So these are like 3 variables, but the majority of space is for B. What is the space required for B? It is equal to the length of the A. So that means space requirement here is order of n, right? Are we using any more space here? No. So the space complexity is order of n and time complexity is also order of n in this particular case, right? So this is how we are able to solve this particular problem. But in the second approach, what we are going to do is an improvement in the space complexity, right? So if you closely observe this logic, right, whatever we are doing, at a time we are only considering ai and ai plus 1, right? We are considering ai plus 1. That means we are considering only 2 elements at a given particular time, right? So do we really need to manipulate the contents of the array is the question, right? So we don't have to really manipulate the contents of the array. That way, that means we don't actually need the array B. We could potentially do the even index traversal and odd index traversal on the given array itself. We don't have to actually manipulate the array, but we need to do some extra magic, right? So that's what we are going to see in the second approach, right? So approach 2 we will call, right? So as I already disclosed, it will not be using the space whatever you have used in the approach 1, right? So here, instead of declaring a completely new array called B, what I am going to do is I am going to declare 2 variables called first and second, right? Because if you closely observe in the previous approach, right, all you are doing is keeping track of just 2 elements, right? ai plus 1, right? That's it, and trying to work with it, right? So since we are worried about only 2 elements, that's why I declared 2 elements called, one element called first, another element called second, right? So this stays the same. We go through the even and odd index. So basically we will start with the even index, and if initially I am initializing the first and second to -1. So if the first and second are -1, what I am going to do is first will be ai and second will be ai plus 1. That's what I am going to initialize. Otherwise I will be initializing second to ai plus 1, right? So this is the important step here. So as long as first and second are not initialized, you initialize. But if first and second are initialized, right, then you only initialize the second. First is already initialized, right? So we will see what we are going to do. So it follows exactly the similar approach, except that we are not now manipulating the contents of the array, but we are just manipulating only first and second variables. That's it. So if first is less than or equal to second, that means we are assuming here a of I is less than or equal to a of j, sorry, a of I plus 1, right? So that means here in the first case what we said is even indexed elements, right? So we are looking at this condition now, right? So let's go ahead and look at that condition, right? So if that is the case, what we are saying is, okay, calculate the difference and add that to even, and then subtract the second, the element second. You are not essentially manipulating the ai plus 1, but you are essentially manipulating on this the variable second, right? So you subtract that much count from second, right? Similarly, you subtract that much count for first. So this will be our even indexed elements. So finally, we are accumulating the number of moves in even. So similarly, we will accumulate in odd as well, right? So since we have to go through the array two times, one is for even, one is for odd, we have been going through. So the only change that we are doing is first and second are reinitialized here to -1. So if you closely observe, right, we are still going through the array A. In approach 1, we went through the array B for the odd indexed element, right? So now we removed the space requirement for the array. So finally, whatever the element that we have accumulated in odd and even, minimum is thrown out as the answer, right? So if you look at the time and space complexity for this, right? So time complexity will be still same. There is not much that we changed. Space complexity, right? So what is the space we are using? So we are using like 5 different variables, that's it. Apart from that, we are not using anything. That means we could easily say the space complexity for this particular algorithm is order of 1, which is constant, right? So that's how we are able to improve the space complexity from approach 1 to approach 2 by the order of n, right? So if you have any further questions, please post them in the comment section below this video. I'll get back to you as soon as I can. I have posted this code to the GitHub repository. You can get the link from description below this video. If you haven't subscribed to the channel yet, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.